Hello fellow programmers, would you be interested in this ball simulation I created using a random snake? No? Well, here it is anyways. As you can see, this ball is bouncing because it is a ball simulator, of course. You can also click anywhere to move the ball. It is glitchy if you teleport the ball inside of a line, which is super sus. There is no limit to the maximum velocity that the ball can fall. It has all the properties of my last version but with lines. This is cool and all, but do you want to know how this works? No? Well, here it is anyways. Disclaimer, I do not use any real physics formulas as I am a stupid idiot who somehow created a functioning ball simulation in a couple of hours. This is a ball. This is a line. This is a trash can. All of these have many properties. Now this ball has a velocity that is constantly increasing at a constant rate. Keep the ball falling for too long and it will be falling faster than my grades.
But Evan, there is a thing called terminal velocity. That is so unreal.
Shut up, nerd. Anyways, if the ball were to hit an object, it will bounce up with an equal force.
Oh, it is because according to Newton's third law of motion, every object—
Shut up, nerd. Now of course energy is being converted into other forms, so I must add loss to make this not bounce forever. Now this bouncily bouncing bouncy ball bounces bouncily bouncing realistic. Now would you like to bounce into the next segment where I explain how the X velocity works? No? Well, let's do this part quickly. What I did was I got the angle of the line that the ball is hit, calculated that as a percent from 0 to 100 relative to the angle from 0 to 90, got the X velocity by getting the given percentage of the total force and moving it in the downwards direction of the line. Keep in mind, the total amount of force is the maximum velocity the ball can travel at. If 80% of the force is on the y-axis, then 20% of the force is moving the ball on the x-axis. This works well, but when there is a slope with a small angle, it will descend slower than how time feels in math class. To fix this, I added a totally definitely 100% realistic boost to the x-axis. Here's how it works. Every time the ball hits an object, the total force is increased and a temporary amount of extra percentage is added for the x-axis. This barely has an effect, but when the ball is bouncing faster than my subscriber count is falling, this has a noticeable effect. This makes it look like it is rolling. Are you bored? Do you have no friends? Are you broke? Well, this commercial has nothing to do with that, and that sucks, but please join my Discord server. This server has features like a broken bot that is never online. Why isn't the bot working? A super dead chat, guys. And updates to upcoming projects and videos. Now let's go over the math part. To accurately fetch the correct collision state of a line and a circle, you must locate the positional arguments required for the closest point from the given position of the circle to any point on the line, assuming that it is infinite. Basically, you just do it. Just get the closest position on the line to the circle and get the length of the line to see if it is less than or equal to the radius.
But my name is Savan, bro. How do we get the closest position on the line?
I'm glad you asked. There are many different ways to do this. Note that the point closest to the circle is the intersection of an imaginary line perpendicular to the given line, meaning that you can do some basic algebra or some dot product crap to figure this out. Here's my super messy and bad code. Thank you guys for watching this huge trash can garbage tornado dumpster fire mess of a video that I totally didn't make in 30 seconds because I'm getting such little sleep every day just to get all my work done, and YouTube right now is my last priority. My name is Evan Bro and I'm out.